Okay, thanks James. Good morning everybody. Today our webinar will talk about targets and benchmarks, and we're going to specifically talk about around energy benchmarks in particular. However, as we go through we'll see that this applies to some other metrics such as emissions and costs and things like that. So okay, so just a brief overview of what we'll cover today. First of all, we'll give a brief context and a little bit of revision and how this fits with some of our previous webinars, especially around process heat and energy targets that we've talked about in previous webinars. We'll talk about the difference between a target and a benchmark. And we'll talk briefly about targets, although as some of you may be aware, we've talked about this in the past around how to establish energy targets and heat recovery targets and things like that. And then we're going to talk about benchmarks, what they are, why you would bother going through a benchmarking exercise, what's the value in doing that. We'll have a bit of a discussion around the different types of benchmarks and the selection of an appropriate benchmark. We'll talk about specific energy consumption or energy intensity and how that becomes an important measure of I guess the difference between what your energy use is and the benchmark that you're comparing against. And then I've got a few examples of where benchmarks have been used and how they can help you identify opportunities for energy reduction and things like that. Okay, so the primary focus will be around process heat and industrial processes, although I will talk about commercial buildings in there a little bit as well. But as I said before, there are a number of different areas where benchmarking can be used, and so the general principles apply. Okay, so this is from some of Tim Walmsley's previous webinars, and we've talked a lot about chasing energy savings, especially on the thermal side, and how the potential for energy savings increases, but you need more time, resources, capital and things like that in order to get that. And so down the bottom we've got sort of housekeeping and things like that, which has good potential. However, it is pretty limited what you can get, and as you go up the potential curve there, then you get into more retrofit projects, and then you start looking at the site, and right at the top you've got technological shift. So that's really talking about a new process or a different process in order to make the same product, which there is potential there for a large amount of savings. However, the time and capital and things like that becomes quite a lot more. And we'll see when we talk about benchmarks, and in particular a gap analysis, how that becomes appropriate to look at as a measure of how much potential you could get. Okay, so this is briefly a review from a webinar I did earlier in the year. We were looking at demand side assessments, in particular if you were doing, say, a pinch analysis or looking at your heat exchanger network. And the first thing to do is really look at what is your demand, looking at your process, mass and energy balances, things like that. The second step, or the second group of steps, is around benchmarking and targeting. And that's a really important step before you do any design, because what that does is it outlines some boundaries of what's actually achievable. And so really benchmarking and then targeting is an early stage if you're doing a big energy reduction project, because what it does is it helps define what's actually achievable. And so it's actually a really important step. Sometimes we rush off and want to do design, but there's an important step before that in defining that. Then after you've done your targeting, you go away and do some further analysis and design, evaluate alternatives. But if you don't get your benchmarking and your targeting stage right, or you don't do that well, then you may miss some opportunities for improvement, and they can really aid in identifying opportunities. So hopefully as we go through, we'll see how this can be useful, this benchmarking. So we'll briefly talk about targets and what the difference is between a target and a benchmark. So a target is really something you aim for, okay, or you shoot at. So, you know, if you're an archer, or, you know, you have a target that you're aiming to hit, and so it's sort of a goal, I guess is another term that you could use. Whereas a benchmark is actually a standard that you use to compare something to. Okay, so in surveying, you have a benchmark, so you have a fixed location that you know the elevation, and then from that you can then survey out from there, because you know that that location is fixed and you know the details around that. I think originally benchmarks were used by cobblers when they made shoes, and you'd put your foot on the bench and they would make a little mark and know what size you were. And so it's slightly different than a target. What you're doing is comparing yourself with some other measure, and that could be for a number of things. It could be your feet, it could be your energy use, or your costs, or whatever it may be. So it's important to realize the difference. A target is something that we've decided to aim for, whereas a benchmark we're simply comparing with someone else. And we may then decide that we want to reach that standard, or a portion of that standard, or go beyond that standard, but they are slightly different, a target and a benchmark. So some examples of energy targets that you see often is somebody will come up with, we want to reduce our thermal energy use by 10%, or it may be in cost terms, we want to reduce energy costs by 10%, and that number will come from somewhere. Yesterday, the draft NZEX, the New Zealand Energy Efficiency strategy, was released for consultation, and one of the targets or goals it talks about in there is a 1% per year reduction in energy intensity. Okay, so that's a target or a goal that is being mooted as a goal for industry to meet. That's sort of what we've been tracking historically for the last 15 to 20 years anyway, but that's a type of target, something that you're trying to achieve. Now, targets are important, but you have to just keep in mind, how are the targets set? You know, did the CEO simply come up with a number? You know, they're usually nice round numbers, 10, 20%. They're not sort of 11.5 or things like that. So how are the targets set? Are they based on any analysis or any engineering judgment, or are they simply, you know, something to feel good, we're going to try and get to a certain amount?
Marty, would the CEOs call that a stretch target?
Yeah, that's right. Well, that's right. It could be a stretch target, or it may actually be lower than what's actually achievable if you don't, you know, if it's not based on anything. So you're right. That's aspirational goals are good, but how are they set, and what goes along with that is, are they actually achievable within the constraints that you have, and are they measurable? That's right. And how are they set, and how are you actually going to achieve them? What's the roadmap in order to achieve these targets? And often, you know, we set targets and we don't think about these things beforehand. And so one of the things that we've tried to stress in our previous webinars, especially around process heat and the use of pinch analysis and heat recovery, is it actually gives you a rigorous target based on thermodynamics that you can then meet. And you may only go part of the way, but this is a reminder. So this is what we call our hot and cold composite curves, and when we do pinch analysis, we look at what our heating demands and our cooling demands are in our process. We can then rigorously determine how much heat recovery we can have based on a minimum temperature of heat exchange, and then from that we can work out the maximum amount of heat recovery we can have, plus a hot and our cold utility targets. Okay, so these are examples of rigorous targets based on analysis that we can then meet. It may not be economic to go the whole way, but nonetheless we can then, they're based on something and we can show how they can be achieved. And so you move on and then you look at your heat exchanger network and how you may retrofit that or design it from scratch in order to meet that target and then relax it for economics. So we've talked quite a bit about targets in the past, but it's important that, yes, we get these aspirational stretch targets, but as engineers, we need to figure out how we're going to do that, what's actually achievable within the constraints that we have. So benchmarking is another tool that's often used in order to look at somebody else or some other measure and determine and identify what some opportunities are and what the potential is for savings within some constraints depending on the benchmark that you select. So why would you bother doing this? Well, first of all, it's a really good way to help drive business improvement, both in the short term and in the long term. So, for example, in the short term, if you benchmark your current performance, say, against past performance, then you can look at things like housekeeping, efficiency improvements, how are the operational parameters that we're working with, how do they affect our energy use, and we can compare that to some other previous time or the competitor down the road. So that can help drive some short-term strategies in order to improve energy efficiency. They also become really important for long-term strategic planning. And so if, for example, you're looking at a major plant upgrade, then while you're doing that, you can also compare, well, what's the state of the art, or what's a similar plant that we know is an efficient plant. It may be a competitor, it may be another plant within the company somewhere else, either locally or overseas, and then you can look at, well, what's achievable and how do we achieve that? Maybe we need to look at changing some technology or changing the process slightly in order to achieve that energy reduction. And also, if you're going really radical, you can look at what are some other technologies that we can look at and what will be the benefits of those from an energy point of view. So, for example, we've been doing some work looking at new black liquor recovery boilers that they use in the craft pulping industry, and how a step change in that technology would affect the balance, the heat and power balance of a pulp mill. And so you can start looking at these things as how new technology is implemented and what the benefits actually are from your specific energy consumption. The other area where benchmarks become useful is they become a measure of your competitiveness against your competitors. And often you'll see, you can pay for benchmarking studies to be done. There's a number of consultants that can do this for you, and they can basically put you on a curve, on the cost curve, for example, compared to other competitors, and you can see where you are on that. And that's often a very useful guide, especially if you're an international market, to see how do you stack up against other countries and other competitors there. And if you're down the far end of the cost curve, if you're very inefficient, then you've got to think about how do I shift along to become a lower cost producer, for example, or how do I help improve my energy efficiency in order to improve my competitiveness. The other thing it may be used for is it may be used as a basis for rating or some certification. Okay, so in the forestry industry, if you want to have a sustainable, if you want to have your FSC, that this wood product comes from a sustainable forest, there are certain things you have to meet, certain benchmarks you have to meet around where you source your wood and how that is managed. In the commercial building space, just recently in New Zealand there's been this Neighbours program which is about office energy performance, and we're going to talk a little bit about that. ECA has some very good resources there. They're sort of championing that program. But there's others such as Green Star, which is a sustainability rating for commercial buildings. And what they do is they really they rate you against some predetermined benchmark around what a sustainable building would be, what an energy efficient building will be, and then they will rate you based on that performance or that benchmark. Okay, so this is just a generic process of what you would do to go through a benchmarking exercise. It's really important to define what are you trying to achieve in the study. Is it energy reduction? Is it cost reduction? Or some other measure? And then once you've done that, the definition or the purpose of the study is important when you select the benchmark. What are you actually going to compare to? And we'll talk about in a moment what different benchmarks there are. And you may use more than one, but it's important that the benchmark that you choose to compare yourself against is a relevant one when in the context of the reason for having the study in the first place. Okay. Now often the danger is you just stop there. You do the benchmark, you come up with some number, you're great or not so great, and then you carry on. The reason why you go and benchmark yourself is then once you've determined the gap between you and the benchmark, you then can do what we call a gap analysis. And what that is looking at is trying to define and quantify and identify why are you different? Why is there a gap between your performance and the benchmark? And in doing that gap analysis, that then leads on to opportunity identification. And we've got some examples later on around how that's done, but that becomes an important next step in order to move to action, because it's nice to have this comparison, but if you don't do anything with it, then it's really a little bit of a waste of time. And then obviously once you've identified opportunities, you can then assess the economics and then implement them. And as we've talked about with energy targets and heat recovery, not all of them may be economic. However, you can help close that gap by implementing the economic ones. So benchmarking is really just a step in a wider process, and it's important that you move on from just benchmarking into this gap analysis and identifying opportunities. I'm sure the bookshelves and the libraries of industrial plants are littered with benchmarking studies that just got done and sat on the side, but nothing happened after that. It's important it moves on from that. Okay, so as we talked about before, a benchmark is really quantifying and comparing some performance metric to some other predetermined standard. Okay, and so it could be energy, as we're sort of going to focus on today, but it could be other things. It could be your production cost. How does that compare with others? Sometimes people actually publish these and they're quite insightful. I've seen some from the pulp and paper industry looking at different regions in the world, and you can see the breakdown of their costs, energy, feedstock, labor, those sorts of things, and they do vary. So that's quite insightful as to what's going on, and especially if you know where you sit within that comparison. So energy, water is another one that's often looked at, is what is your energy use compared to other countries. Certainly in Australia, that's a really important metric that often gets looked at. Carbon is becoming increasingly important. How do you compare with your carbon emissions per unit of product compared to your competitors? So this sort of carbon footprinting, those sorts of things. Yield or conversion efficiency, certainly in the sawmilling industry, that's an important measure, is what is your yield or your conversion efficiency of your plant. It could be labor inputs you're benchmarking, what is your wider environmental impact, and then maintenance, what is your maintenance spend, and there's a number of different metrics there that you can then look at. So depending on the purpose of your study, obviously that has to be quite tightly defined. Are you looking at an energy project or an energy benchmarking process, or are you trying to look at something else? Okay, so if we just focus on energy for a moment and we look at, well, what are some of these benchmarks that you might decide to benchmark against? And as we mentioned before, but it's important to reiterate, the measure or the benchmarks that you decide to benchmark against, it's important to pick the right one for what you're trying to do. So for example, you might decide to benchmark or compare your current plant performance with your past plant performance. Okay? And it may have improved. If you've done some projects, then that may have improved. Often a common one is what is an industrial average. And every now and again, different sectors, they will employ someone to go through a benchmarking study, and people can voluntarily opt in, and you can compare yourself with an industrial average based upon a sample size. And that can be nationally or internationally depending on the industry. And so that's a common one that you can find. Often in the literature you can find sort of indicative industrial averages of energy performance, so energy per unit of product. The third one that's often used is a best in class, and what that attempts to do is, obviously different plants use different technologies in order to make their product, and so sometimes it's not a fair comparison to compare an older plant with a brand new plant with the latest technology, although that's an important measure in itself, but you're really trying to compare like for like. We'll talk about that in a little bit more detail soon. Another benchmark is a best practice or best practice technology, and so that really is around, if we have best practice operation based on our current technology, what could we achieve? You know, if we're implementing best practice maintenance, you know, if we've optimized our process from the parameters, temperatures and pressures and flows and things like that, what does that benchmark look like? Another one is, what's the best design or the best available technology? And that becomes quite a useful one, because that's sort of what's doable based on available technology. And so especially when you're looking at a major plant upgrade, then comparing it to that is a useful measure. And then also you could come up with a energy target or a theoretical minimum. So for example, the pinch targets for heat recovery, they are an energy target based upon some thermodynamic analysis, which you can then compare your current performance against what that, we call them energy targets, but it's really an amount that you could get to, an achievable energy use. And so that then can then define what your gap is between your current use and what's achievable. So as you can see, there are a number of different benchmarks that you can select. Some of them are easy to find. Some of them take a little bit more work in order to determine what those values are. But it's important to think about which benchmark to use.
Sorry, I'm just going to jump.
Thanks there, James. Yeah, absolutely. That best in class is your class, not the other class. And so that's important to define that when you're using that as your benchmark. And that really leads on, sort of a bigger question is, what are you actually comparing? You know, are you comparing apples and oranges? You know, your 50-year-old plant with a brand new plant that uses a lot different technology, a lot different process. Certainly in some industries there's been some large changes in technology in the last few years, and so that's not really a fair comparison because you're not really going to just scrap your plant and build a new one. So are you comparing apples with oranges or apples with apples? And then even when you are comparing apples with apples, it's important to remember that we have different type of apples. James yesterday mentioned that he thought there was something like 7,500 species of apples or types of apples, and so, you know, comparing them, they look the same, there are some similar attributes, but are we comparing apples with apples, the right apples with the right apples? And then just to take it one step further, you know, if we've got an older apple, it's not really a fair comparison to compare it with a new apple. And so this is this best in class. Defining what your class or what quartile you're in becomes quite important in order to give a fair comparison, if that's the benchmark that you have determined is the most appropriate. Sometimes it's insightful to compare it with what a new plant would be to give you an idea of what's potentially possible, but you know, we just have to step back and really make sure that the benchmark that we choose, and that may be more than one, is the most appropriate to what we're trying to achieve. Because if we don't, you end up either looking for things that aren't really achievable, or your gap analysis becomes a lot more complicated and involved than it really needs to be. Okay, so as I've said, we've sort of hammered this point home, but selecting the right benchmark is critical, and you've got to think about what is the purpose of the study. And it's important to do that beforehand. Is it an energy reduction program? Is it some short term? We want to do some projects. We don't want to have a big revamp of the plant, but we want to look for projects that we can implement in the short term. So a best in class might be a useful measure there. Whereas if we're just looking for energy reduction, maybe comparing it to our past performance is a useful guide. If you're looking for long-term energy planning, especially if you're looking at, you know, major plant upgrades or production expansion, then perhaps a best design or a best available technology is a useful benchmark in order to select. If you're looking at sort of research and development investment, if you're in that sort of space, then sometimes it's important or useful to have an idea of what is theoretically possible based on thermodynamics, or, you know, what we think the technology is now and what the development may be in the future. Okay, so that's an important one. So to give you an example of that, there's a lot of work around the development of industrial heat pumps in order to upgrade waste heat to a usable temperature and then integrate those in the process. And so if you look at a say longer term energy reduction, then that can give you some boundaries of what's achievable if you have industrial heat pumps at what we expect for them to perform in the future. That could be another useful measure, and you may decide, look, we're going to help invest in that because we can see some benefit from that. Okay, so if we get into the nuts and bolts a little bit of the different types of benchmarks that because obviously to compare with something else, you need to know what your current performance is yourself. So you need to do some quantification and some analysis of what you currently have. And on one level this may seem straightforward, but it can get very tricky or complicated very quickly if you're not careful. So if we have our simple plant here, for example, and we take a feed stock and we make, you know, a product, and that will go through a number of processing steps. Obviously we take in energy, and then we have some emissions. So if we're only focused on an energy aspect, then one very simple way is we look at our energy use, and then we divide that by the total output of our plant. And so that will give you your benchmark or a specific energy consumption. So that may be gigajoules per ton of product. And if you just look at a very high level, that's often quite easy and quite quick to determine. However, there are a number of things you just have to be careful of. One of the advantages of it is it does account for all the aspects of your facility. Okay, so all the inefficiencies, this is including your utility system or even your admin building, and you just take your total energy bill, then it will capture the inefficiencies there as well. People leaving the lights on and all this sort of thing. So that's an advantage, although sometimes you want to remove and discount those. Because if you include those and the benchmark you're comparing to doesn't, then it's not really a fair comparison because you've added things in which are not in the benchmark. It is pretty simple, and if you're producing a single product, then it is fairly straightforward. Where it becomes more difficult is if you have multiple products, especially you have byproducts. So what you have to then do is look at, is there a standard to assign a certain proportion of that energy or the emissions to different products or different byproducts. Now there may be standards in the way that that's done, or you may have to look at what is the best way to do that, keeping in mind that we want fair comparisons when we compare to a benchmark that we've selected. So this product basis is useful and common, but it may not capture all of the things that we want to capture, and when we go looking for our gap analysis and trying to determine why there is a gap between our use and a benchmark, then we end up having to look a little bit at the next level down. So the other type of benchmark that is commonly used is referred to as index benchmark. And what this does is it looks at each individual process and comes up with some index of efficiency, or it may be the specific energy consumption of that process based on its performance. Now, what that does is it forces you to look at each individual process or step in your plant, and once again there's some advantages and disadvantages. It's a little bit more time consuming. You have to use a lot more judgment in order to do this, but one of the useful things is you can compare some processes between different applications. So for example, if you're just benchmarking, say, your heat plant or your boiler, then you can compare that with the guy down the road. He may be making a completely different product, but if you look at sort of your boiler efficiency or condensate return, all those things can come into that benchmark or that comparison. So that becomes useful if you want to compare similar processes or technology between different products. The other important advantage is it helps, or it can help identify specific areas of improvement. And so for example, you may have 5 different processes and 3 of them may be performing at an acceptable benchmark level or an acceptable performance level, but 2 may not be. And so obviously that's where your greatest inefficiency lies, and so that identifies areas for you to look at first. However, one of the big downsides is it does take a little bit more time to generate. Often you have to do some measurements at that process level because you're not sure. And so it's really important to get the system boundary defined, and what are you trying to benchmark? Are you just trying to look at a single unit operation? And certainly in many sectors, you may have evaporators, for example, and they're often an intensive energy use or user, and so you may just decide you're going to benchmark your evaporators, and you may benchmark them with other plants or other technology or whatever. Are you looking at the sub-process, a collection of processes that do a predetermined job? Are you trying to benchmark that? That might be evaporators, or it might be distillation, or whatever it may be. Or you may decide that your system that you need to look at is actually the entire process, And so you have to make a judgment call as to, is the utility system included in that or not? And depending on the benchmark you're using, there may be some guidance there as to what's included and what's not. Or you may decide that the entire plant is the most appropriate boundary. So some thought has to go in at the planning stage, really around what your system boundary is in order to capture the right information when you're determining what your current performance is and what the benchmark is. Now, if we just talk about commercial buildings, so for example, the Neighbours program or rating, they have a number of different ratings which is based on I guess a system boundary. And so for example, they have what they call a tenant rating, which is just a rating for the tenants, and it only includes things like the lighting that the tenant is using, both signage and inside, the power points that the tenant has in their space, the tenant server room, any air conditioning and things like that associated with that. Whereas the second boundary or system boundary is what they call a base building rating, and that includes sort of the whole building, HVAC, lifts and elevators, common spaces and things like that. Okay, so that's a separate boundary that is determined and I believe quite well specified within in the documentation for Neighbours. And then those things are then used. You can also have a whole of building rating. Okay, so sometimes if you're using a predetermined or a specified benchmark, a standardized benchmark, then there may be some guidance as to what the boundary is and what is included and what is not included, and how to treat things. So one of the important things to determine, and this is really your comparison, is what we call the specific energy consumption. And it's a pretty straightforward concept. It's your total energy use per unit of output, so gigajoules per ton or whatever. But it's important to then split that out into thermal and electrical use, okay, because they have different uses often, and it's important to do that. So you may have a specific energy consumption for your thermal and then for your electrical. So what you can find in the literature often is different indicative specific energy values for different products. So here's some for pulp and paper. For example, if I get my highlighter here real quick, if we just look at kraft, softwood, bleached and dried, then you've got indicative steam demands and electricity demands per ton of this air-dried ton of product. And then we've got different types of paper, newsprint, and you can see the steam demand and electrical demand there. So that becomes a useful tool to quickly compare and to get an idea around what typical energy uses are. So that's at a sort of a plant-wide level. If we go further down, okay, so this is for kraft or chemical pulping, then there are different steps: cooking, bleaching, evaporating, etc. And so here there's a comparison of what a state-of-the-art mill would be expected to use versus what a typical or average mill is using. And so you can see there's a little bit of a gap in some of the areas between what a state-of-the-art mill is compared to a typical existing mill. So if you were one of those typical existing mills, or you had those numbers available, then you could compare individual processes with some indicative value or benchmark. And then what that then leads to is, once you've compared yourself with this benchmark, is you go ahead and determine why is that different. And is it your housekeeping? Is it the process that you have? Is it the age of your plant? Things like that. But the reason for doing that gap analysis is really then to lead on to opportunity identification. How can we close that gap? What do we have to do in order to do that? So often you'll see these benchmarking curves, and so what this will do is bring each decile, and you'll plot the least efficient plant, and you'll rank them, and often they're along with production capacity, cumulative production volume, and depending on the shape of this curve, then a benchmark will be set. So often, in this case, they've got an index, and so they've normalized everything, and so a value of 1 would be your international best practice technology benchmark. Obviously, the lowest one is your most efficient plant, and up here you've got your least efficient plant. So where do you rank on that? So here's an example for methanol, the production of methanol from natural gas, and you can see that the ranges are from sort of almost 40 gigajoules per ton of methanol down to just below 30 gigajoules per ton. And so what you would do, if we go back to our generic curve, is you find out where you are on that curve, decide on which benchmark you're going to compare. In this case, if I just use the international or best practice technology benchmark, then obviously there's a gap. So let's say, for example, that was my plant on my methanol benchmark curve, and I decided to take my benchmark as the international one at 32 gigajoules, and let's say I've determined I'm at 36, then obviously there's a 4 gigajoule per ton difference between what I'm currently operating at and what the benchmark is. And so the question really arises, why is that different? And then you can go looking for why that is different. Now you already may know that, but what are the economics, what projects do I have to implement in order to achieve or reduce that gap? Okay, so I've got a couple of brief examples here as to how this could be used. So as I said before, this Neighbours rating, the rating is pretty straightforward. You get a number of stars depending on how good your performance is of your building, and there's a lot of standard measures and how they come up with this. So for example, if you get 4 stars, then you have excellent performance. It attempts to take into account things such as location. Obviously a office block down in the cold south will be different than up in the warm north here. So it takes into account those sort of variabilities and determines a star rating. But to give you an example of the specifics, it sort of benchmarks different things like HVAC and lighting and things. So this is some of the, I guess, what a 3.5 star Neighbours building would look like from a lighting point of view. Okay, so they would be using typically between 15 to 20 watts per meter squared, and they would have zoning simply by floor. As you move into a 4.5 star building, then the fluorescent lamps that you use become slightly more efficient, and your lighting or your energy use drops to that region from sort of 10 to 15, and you may have controlled on your individual zones. A 5.5 star rated building would have T5 fluorescent lamps and LED lamps, and the energy use would be down at sort of 5 to 10 watts per meter squared, but there would also be things like presence detection and daylight control. So in the Neighbours rating system, the benchmarks or what you're comparing it to are quite well predetermined, and so that makes things straightforward. I think it's quite detailed and involved. However, you can get a very good comparison because the benchmarks are very well predetermined. Okay, now the second example before we finish is from the refining industry, and they have used benchmarks extensively for a number of years. It's quite an energy intensive industry. On average, about 6 to 7% of the incoming crude is actually used for energy. So you're actually using your feedstock, and as you know, oil prices go up and down, and so if you can reduce that, often your competitiveness is very closely connected to how efficient your refinery is. So there are, in particular, there's what they call the Solomon's Energy Intensity Index, okay, and they're a fairly large consulting company, and they are well known for these energy benchmarks, and not just for refining but in other industries as well. And when you look at how they do this, they use a statistical model to look at your refinery and compare that with other plants of the same kind and things like that. And I've got an example of what they call a Solomon's curve in a minute. And then the example I'll focus in a little bit more is there's a company called KBC, and they have their own method of doing benchmarks in the refining industry based on a best technology index, which is slightly different than the Solomon's energy intensity. They take a slightly different approach to that based on simulation of the best design of that plant given what's already there. So this gives you a typical Solomon's curve. It's this one here. So this is the value over here, and what it does is it gives you cumulative oil capacity versus the index. Obviously, if you're up here, you're the worst plant, and if you're down over here, you're one of the better plants. Okay, and so you can very quickly see where you rank within that if you went through that sort of exercise. So this was the example of how this was taken all the way through to implementation. Is based on a paper given at a conference a few years ago. Andrew Morrison is one of the students from our group. He works as a consultant in Singapore for KBC and does consulting all around the world in refineries. And so they have a slightly different process, but it's got the same steps where you benchmark, do your gap analysis, look at identification of opportunities, also looking at other energy metrics at the same time, and then coming up with a roadmap and then implementation. So this is an example from a refinery in Europe. Okay, obviously it has to be confidential, so you don't know which one. There's lots of refineries in Europe, so take your pick. And they use this best technology index. That's the measure they use, and what that is if you're at 100%, then that's your best technology. That's where you want to get to, is 100%. So for this particular site, they went in and did the analysis, and the best technology index was 149%. So what that means is that the plant is using about 50% more energy than its best performance in its current state. Okay, so without having sort of new technology or anything like that. Based on what's there, it could potentially reduce that by almost 50%. And how they do their gap analysis is in the refinery, there are only a few areas where you need to look at. So one is fired heaters. So this preheats the crude before distillation. What is the performance of the fired heaters? How is the power generation on site? What does that look like? How much heat integration there is? One of the major things in crude oil refining is preheating the oil using heat recovery. There's often huge potential for improvement there. So heat integration, and then what does the utility system look like? So what they do is they appropriate or assign and determine how much of that gap is across those four areas. Okay, so for this particular refinery, only 3% of the gap was appropriated to or determined that it was from the fired heaters. So what that tells us is they're performing very well, and you can see that the power generation, the heat integration, and the utility system each had about, well, the power generation was just above 20%, and then about a third each was from heat integration and the utility system. So 85% of the gap of that 49% was attributed to those three or those four areas, and 15% was unaccounted for. That will be things like different operating pressures and things like that. Okay, so now this helps you focus in on where to look for opportunities. So obviously you wouldn't spend much time on the fired heaters, and you would look at heat integration, utility systems, and then your power generation as well. So from that, they then they develop what they call a roadmap, which is really what potential opportunities are there. And so some further analysis has to be done. Certainly for improved heat integration, a big pinch analysis would be done. You do utility system modeling to optimize your utility system and things like that. And then once you come up with a number of projects, you would then compare the economics of those against what you need to do in order to get things implemented. And in this particular case, they determined there were 8 non-investment opportunities. So this might be things like changing some temperatures or operating parameters. 8 investment opportunities, that may be new heat exchangers or whatever that may be. And then some were around utility systems. And so, as you can see, 7% out of the 14, so 7% reduction in energy costs came from non-investment opportunities. And these were identified by going through this benchmarking process and then looking at what the gap is and determining some projects. Okay, so we're pretty much out of time. We have some time for questions at the end, but benchmarks and targets, they are slightly different, but they are complementary. And by performing a benchmarking exercise, it can help you determine what a reasonable and achievable target is. As we mentioned and stressed earlier on, it's important to select the appropriate benchmark depending on your study and the purpose that you're trying to achieve. Determining your specific energy consumption, if it's an energy reduction study, that is an important metric. And determining that well, both for your thermal and for your electrical, that is an important step. And then that leads on to a gap analysis. It's important to determine and identify why there is a gap between your performance and the benchmark that you've selected, and then to try and identify opportunities to reduce that gap. So I guess to sum up, benchmarking is a powerful method, but it has to be applied correctly, and it's only really useful if it gets you moving into some action and getting some things underway. So just if you want some additional information about Neighbours, there's a very good website there, neighbours.govt.nz, that outlines that. There's a very good webinar that was recently posted by Drew Roberts at ECA, which is on the ECA YouTube channel, I believe, which talks about Neighbours, what it is, and why would you bother doing it. So those of you who are interested in commercial buildings, that's a very good introduction there. For benchmarking in general, especially industrial benchmarking, there's a good working paper from the UN Industrial Development Organization. If you put that into Google, you will find that pretty easily, and that sets out some of these some of the issues and how benchmarking can be useful. And then there's also another document which is around key considerations for industrial benchmarking, and it talks about some of the theory and some of the practice and how you determine appropriate boundary conditions, how you may determine if you've got multiple products, how you would assign different amounts of energy to different products and things like that. So that's also another useful resource. If you want, I can send you those if you want to drop me an email. So where to from here? So we're having a break, some fishing to do over the summer, but we'll start back up in February. Dr. James Neal will give a compressed air system efficiency webinar on the 1st of February, and then 2 weeks later we will have another one which we have to confirm the topic. So just a reminder, once again, all the past webinars are available to view, and obviously if you want more information, then please feel free to contact ECA Business or your account manager. So thank you for attending. We'll stay on the line if anyone has any questions. Thanks, John. Okay, it doesn't look like there's too many questions, but thanks for attending. Hope you guys all have a good Christmas and enjoy the holidays. Stay safe, and we look forward to seeing you in the new year. Thanks, Paul. Thanks, Stu.